Hi guys, today you're going to be working on a concept builder related to Coulomb's law. So what I wanted to do was take you through a couple of practice problems the way it goes real easily for you. As a reminder, Coulomb's law describes the strength of the force between two electric charges. So when you look at the equation, F is the electrostatic force. We've seen F used to abbreviate force before. And it is equal to K, which is a constant. You don't really have to worry about that. This would be a number you would always plug in with the same value. Multiplied by charge 1, so Q1 is charge 1. Multiplied by Q2, which is charge 2. Divided by the distance between those charges squared, right? So you don't want to forget about this, that the distance is squared and in the denominator. So I picked a couple of problems that come from the concept builder set. You'll probably see some variations on these, and I just want to tell you kind of how to step-by-step solve those problems. So in this example, it says object 1 and 2 attract each other with an electrostatic force of 18 units. So that is the original F, right? The original force. Now something is going to change. So it says if the charge of object 1 is doubled, the new electrostatic force will be blank units. So we want to think about our equation. So if the charge of object 1, or Q1, is doubled, right, it's multiplied by 2, what that's going to do is multiply the force by 2, right? This numerator is going to be twice as large. The value of the force will be twice as large. So to figure out this style of problem, you would take the original number, 18, and we would multiply it by 2. Right? And you can feel free to take your calculator. You do 18 times 2, and you get 36. That would be the new strength of the electrostatic force. It would double because one of the charges doubled. Now, just to get you thinking, what would be the effect if object 2 was doubled instead of object 1? Well, thinking about this problem, if Q2 was multiplied by 2 instead of Q1, it would have the same overall effect. We'd still multiply by 2. So it would have the same exact effect even if it was the other charge that was doubled. We would have 18 times 2. It would still be doubled, and the new force would still be 36. It didn't matter that it was the other charge that was doubled. Okay? So that's the first type. That's like what you're going to see in level 1. This one is just a little bit different. So it says objects 1 and 2 attract each other with an electrostatic force of 36 units. So that's the starting value for the force. If the charge, right, so charge, we're still thinking about Q, of object 1 is halved, it's reduced, then what will the new electrostatic force be? So if Q1, instead of being multiplied by 2, was halved, was multiplied by a half, well, what that would do to the force is it would multiply it by a half. So you would take your starting force value, which was 36, and you would multiply it by a half, right, or divide it by 2. So if you did 36 times a half, which is 0.5, make it easy, you would get 18. So reducing the charge, right, having the charge halved the force, right? So that's kind of what we're seeing going here. So we reduce the charge, less force. Now, taking it up just a little bit, so it says, what about if object 1 was halved, right? So the charge of object 1 was halved, like we just did up here, and the charge of object 2 was tripled. So if we messed around with Q1 and Q2, what would happen? Well, we're still starting with the same value, so we start with 36. And first, we're going to halve the charge of object 1. Just like it did in the first half, it would multiply by a half, right? So if Q1 is halved, we're going to multiply by a half. Right? That would give us 18. For the electrostatic force, but we're doing something else as well. We are also changing the charge of object 2. The charge of object 2 is going to be tripled. which means that we would multiply Q2 by 3, right, when we triple. So we would be multiplying by half and multiplying by 3. So we know this next value is going to be multiplied by 3. So you take your calculator, 18 times 3 equals 54. So even though one of the charges was reduced, the other one is increased, which still overall made that electrostatic force bigger than it started at. We're at 54 now. Okay? So you just do both of those products. You have it, and then you triple the starting value too. Okay? This next part is like trophy number 2. In trophy number 2, instead of changing the charge, we're changing the distance. Notice that the distance is in the denominator, so we're dividing by the distance. We're not just dividing by a plain old distance, we always are dividing by the distance squared, and we're going to have to account for that in our math problems. Okay, so this says object 1 and 2 attract each other with an electrostatic force of 18 units. So we're starting with a force of 18. It then says if the distance separating objects 1 and 2 is doubled, so if D is doubled, what will the new electrostatic force be? Okay, so if the distance is doubled, imagine the distance has now become 2. How is that going to affect the force? Well, what we're going to do to the force is we are going to divide, right? So we're going to take 18, and we're going to divide it by the new distance squared. You can't forget about the square, right? So this would be divided by 2 squared. Now that's pretty easy. Whenever I think something is squared, you multiply it by itself. So 2 times 2 is 4, right? That's what that number is. So you do 18 divided by 4. So I grab my calculator. 18 divided by 4 equals 4.5. So the force would now be 4.5. Now what about if the distance was tripled? So instead of doubling it or multiplying by 2, if the distance was 3 times as large, right? I'll make that a 3 now. Imagine. Not very good, but there's a 3. Now what would we be doing? Well, we would be taking our force of 18, and we would be dividing by 3 squared. So we're going to divide by 3 squared. Now, 3 squared is not 3 times 2. It's 3 multiplied by itself. So 3 times 3 would be 9. So 18 divided by 9 is 2. So by making the distance even greater, the force has gone down even more, right? So the farther and farther apart these charges get, the weaker and weaker the force is between them, or the weaker and weaker the interaction. Okay? What about if instead of doubling or tripling the distance, we halved it? So what about if the distance was 1/2 the original value, right? So 1/2 is 0.5. So what if it was reduced to half its original value, the charges are brought closer together? Well, what we would expect is if they're brought really close together, they would interact more, right? So we would take that original starting value of 18, and we're going to divide by the new distance value squared. Well, we're not doubling it. We're not tripling it. Scroll that out. We're making it 0.5 the original value. So we are going to be divided by 0.5 squared. So if we took 0.5 and squared it, right, what is that? If you don't know it off the top of your head, that's okay. 0.5 squared is 0.5 multiplied by 0.5. 0.25. So I do 18 divided by 0.25. 72. So just think about that. By halving the distance, bringing them just twice as close together, halving it, we've actually taken the force from 18 and brought it up to 72. Right? So changing the distance has a very significant effect on the force, and that is because the distance is squared in that equation. So it always has a larger impact than you think. Now, this last problem is just for those of you that want to try level 3. This is extra credit. If you don't feel comfortable doing this or you're not up to it, totally fine. But I thought I would throw this out there to show you how you can combine all these ideas. So object 1 and 2 attract each other with an electrostatic force of 36 units. Okay, so the problem starts out the same exact way. It then says, if the charge of object 2 is tripled. Remember, the charge of object 2 is called Q2 in our equation. So Q2 is going to be tripled. But here's what makes this a level 3. We're not just going to change the charge, we're also going to change the distance. So the charge of object 2 is tripled, and the distance separating the objects is doubled. So we're also messing around with D. So we're taking the distance and we're doubling it. We're making it 2. Then what will be the new electrostatic force? Just take this problem one step at a time. It's not really any harder than the other problems. It's just you have to do 2 steps. So like we did before, we'd take our starting value, which was 36 units, our starting force. And we know that we tripled Q2, so that would multiply it by 3. Right? So that was step 1. We're just going to look at what would happen when we tripled Q2. So you take 36 and multiply by 3. That's 108. Okay. But we're going to do one extra thing. Remember that the distance is also going to be doubled. So then the additional step, not that it's any harder, is that you would take that value now and you would account for the distance. So to do that, we would divide by the distance squared. We would divide by 2 squared. 2 times 2 is 4, right? So if you took 108 and you divided by 4, you'd get 27. Right? So it's the same as we did in step 1 and step 2. It's just you have to change the charge and then account for changing the distance as well. So that's what the level 3 problems look like. Okay? Hopefully that helps you guys out. The links for the concept builder will be posted onto Google Classroom. Oh, one more time just to clarify what we did here. Right? So you take the 2 things we did was we first tripled charge 2. So we multiplied by 3. So I took my starting value, right? That was what it started at. And I multiplied by 3. But then I doubled the distance, which was D. So I divided by the distance squared. I divided by 2 squared. And 2 times 2 was 4. So there's both your steps, multiplying by 3 and then dividing by 2 squared. Those are both of the changes, okay? So those are the problems you're going to work on. The link will be on Google Classroom. Let us know if you need any help, and we'll talk to you soon.